So again, for this warm-up question, again, we want to know, what does the equation tell you about the corresponding graph? In our quadratic equation here, y equals the quantity of x minus 1 squared plus 5. This is written in our transformation vertex form. So again, if we think about the original parent function for our quadratic, y equals x squared, we can see that there were two transformations that occurred. We shifted our graph to the right 1 unit and also up 5 units. So our new vertex is now at the coordinate 1, 5. Since we know where the vertex is, we also can talk about our axis of symmetry. It's going to go through the vertex, making a mirror image on each side of our parabola. And so we know our axis of symmetry is going to happen at x equals 1. We also can look at some key features on our graph. We can see our y-intercept is at 0, 6. And then we can also look for x-intercepts. And because we shifted the function up away from the x-axis, notice how we do not have any x-intercepts for this function. We then could talk about concavity of our function, and we can see that it's concave up. And then we can also talk about the domain and range. And for our function here, there are no restrictions on the inputs for our domains. We can say negative infinity to positive infinity using parentheses around each of those symbols. Because they are not stopping, they're going to continue on. And then for range, those are our outputs. So again, if we look at our function, how low to how high are those outputs being used? And we do have a restriction there. The lowest output that we're using is 5, but everything above that is being used. So we can show that all the outputs have to be greater than 5 for our range. That's why we have our bracket 5, comma, positive infinity parentheses.